in time interval, okay, in space, okay, ataupun in volume. Biasanya kita ada selang masa, ruang ataupun isi padu. Okay. And again, Poisson is a discrete event, discrete probability. Okay. Poisson distribution, the properties, you have the mean and variance is the same thing, which is your lambda. Okay, your x start from 0 up to infinite. Okay, so that is the property that you have to know for Poisson distribution. Okay, so actually it is the same concept. Okay, so same concept is how you want to read your stats table. Okay, so the same concept for binomial distribution. Okay, we will finish up the exercise for today on Poisson. Okay, we continue with task. Task 4.19. Okay, already done 4.18. Okay. Okay, if refer to task 4.19, so we have a random variable. Okay, in this case, we have number of surface flaws, okay, in plastic panel used in the interior of a car. So this one has a Poisson distribution with mean 0.15 flaws per square foot of plastic panel. Okay, so ini dia punya area dia, per square foot of plastic panel. Okay, ini kiranya kita punya, itulah dia punya apa, selang masa, ruang ataupun yang isi padu tu. So ini saya boleh katakan per square foot tu maksudnya kamu punya macam isi padu lah ya, dia punya tu volume. Okay. So assume a car interior contains 20 square feet of plastic panel. Okay. Okay, in this case, your lambda is 0.15. Okay, your lambda is 0.15 per square foot of plastic panel. You have 20 square feet of plastic panel. Okay, so again, when you write, okay, when you write what is your x, so your x represent number of surface flaws in a plastic panel. So in this case, per square foot of plastic panel. Okay, so again, you will have your x Poisson distribution with your lambda is 0.15. Okay. So the question asks you what is the probability that there are no surface flaws in a car. Okay. So ini kalau 0.14 flaws per square foot. Okay, a car contain 20 square feet of plastic panel. Okay, now let's say if you use different random variable, let's say y, okay, because you want to find in a car. Okay, I already mentioned to you a car contains 20 square feet of plastic panel. So what is your lambda in order for you to solve part 1? So kalau 1 square kita ada 0.15. Kalau 20 square, so you have 0.15 times 20. So that means your y will be distributed as Poisson. Okay. Poisson, okay, lambda 3. So you want to find what is the probability that there are no surface flaws in a car. Okay, that's means you want to solve probability y equals to 0. Okay. Okay, so now you use your stats table, find lambda equals to 3. Your k is equals to 0. Okay, lambda equals to 3, your k is equals to 0. Okay. So again, you will have 0.0498. Okay. 0.0498. Okay, lambda 3, K equals to 0. Okay, so that is answering for the part 1. Okay, what is the probability that there are at least 7 surface flaws in 5 cars? Okay, yang tadi kita selesaikan, kita ada apa tadi? In a car. Okay, in a car, you have your lambda is equals to 3. So second question, what is the probability that there are at least 7 surface flaws, okay, in 5 cars? Okay, sekarang apa dia punya lambda? Okay, good, 15, right, Okay, because the first one, a car, your lambda is 3. 5 cars, so 5 times 3, so I just use different variable. So that's mean you want to solve lambda equals to 15. So at least 7. So at least 7. So Z greater or equals to 7. Okay. So Z greater than equals to 7. Again, you need to find is 1 minus 1 minus probability Z. Okay, probability Z less than or equals to 6 because you want to include 7, 8 up to 15. Up to infinite. So 1 minus probability Z less than equals to 6. So find from your stats table. So now you use lambda equals to 15. Okay, lambda equals to 15 on page 29. So K is equals to 6. Okay, so 1 minus 0.0076. Okay, 1 minus 0.0076. So 0.9924. Okay, that is your answer. Okay. Okay, so that's mean this one, a car, you have 20 square feet. So that's why given is 0.15 per square foot. Okay. So again, this one for a car, that's mean 0.15 times 20. Okay, sekarang ni kita ada 5 cars. So kalau 5 cars, that's mean your lambda should be 15. Okay. Question number 3. Baca dulu dia punya soalan dia. Apa maksud dia? You have 10 cars. Okay, if 10 cars are sold to customers, what is the probability that 6 of the cars has no surface flaws? Okay, ini okay. What kind of distribution for this one? Is it still Poisson? Okay, so it becomes a binomial. Okay, binomial distribution. Okay, why? First, because you have this one lah. Kita nak cari 10 cars are sold to customers. What is the probability that 6 of the cars has no surface flaws? Okay, so yang ini kita concern dia adalah number of your cars. Okay, number of cars. Number of cars that has no surface flaws. Okay, you already find your probability in part 1. Probability that there are no surface flaws in a car. Okay, so let's say I define another variable. Let's say I use W. So W is number of car. Okay, sorry. Okay, number. That's 4.19. Okay. So W is number of cars. Okay. Number that has no surface flaws. Okay. Okay, this has no surface flaws. Okay, now you have your N is 10. Okay, so you will write W is binomial distribution 10. Okay, probability no surface flaws you already solved, which is 0.0498. Okay, this is your probability. in part 1. Okay, so you want to find 6 of the cars has no surface flaws. So that's means you want to solve is probability W equals to 6. Okay, so since again the probability is 0.0498, okay, you have two alternatives lah. Okay, if you want to find using your stats table, so you can round it to 0. Ada ke table? You end 0.05 lah. Okay. If not, since this question just want to solve exact value, that means probability W equals to 6, you can also use your probability mass function. Okay, so that means you have 10 to 6, so 0.0498 to the power 6. Okay, 1 minus 0.0498 to the power 4. So you get the answer if in terms of 4 decimal point. Okay, so it becomes a binomial distribution instead of still Poisson distribution. But the probability that we use from the Poisson lah. Okay, part 1 though. Okay, probability that there are no surface flaws in a car. So again, your W is number of cars that has no surface flaws. Okay, we use the probability in part 1. Okay, you want to find 6 cars. So 10 to 6, pi to the power 1, pi to the power 6, 1 minus pi to the power n minus X ada there. Okay. So kiranya it is a combination. The probability you get from Poisson, but the question to solve this one, you need to use binomial distribution. Dia bukannya Poisson approximation but again, it depend on the variable. Okay, macam mana kita nak define kita punya variable. So that's why it is quite important for you to know what is the variable you want to find. Okay, apa benda yang sebenarnya kamu nak selesaikan. Okay, so that is your task 4.19. Okay, do you have any question for this one? Okay, if not, we proceed with task 4.2. Okay. Okay, task 4.2. Okay. Ini pun lain sikit lah. Different style of questions. Okay. Suppose that the manuscript of a book has an average of errors per page is M. Okay. M is actually your lambda. That means your lambda is not given. Okay, we need to find what is M. So if the probability that no errors are made on a page of the book is 0.0136, you want to find your M. Okay. So again, what is your X, your random variable? So that's mean number of errors per page. Okay. So if we define, okay, number of errors per page. Okay, so your X distributed as Poisson with parameter M. Okay, so question, if the probability that no errors, maksudnya probability X equals to 0 is 0.0136. So you want to find your M. So in this case, that means you need to use the probability mass function. Okay, probability mass function. So that means probability exponential negative lambda, lambda to the power X over X factorial. Okay, kalau tak ingat, tengok balik formula dia. Okay, formula for Poisson. Exponential negative lambda. Okay, exponential negative lambda. Okay, in this case, your lambda is your M lah. Sebab kita ada average tadi, M. Okay, lambda to the power X. So, M to the power 0 over 0 factorial. So, is 0.0136. Okay, cuba solve kan. 0 factorial is equals to 1. M to the power 0 is equals to 1. Okay, so you just solve exponential negative M 0.0136. So you take ln. Okay. Okay, ln E. Ln E is equals to 1. Okay, and then solve. Find your M. So that's mean you would get approximate lah ya. M kita kat sini around okay, from the calculator 4.29 macam tu. 4.298 lah. Okay. Okay, so again kita approximate 4.3. Okay, so that is your M. Okay, so that part 1. So that's mean you given your probability, okay, your average of error, okay, this is your lambda. So probability that no errors. So probability of x equals to 0 is 0.0136. So solve the value. Okay. Okay. So probability that at most 10 errors was found in 3 fish. Okay. Your M equals to 4.3 ni for a fish, for one fish. So now you have 3 fish. Okay, so 4.3 times 3. Okay, so you get, katakan Y, kita pakai Y, Poisson 12.9. Okay, so you want to find at most 10. Okay, at most 10. Okay, 12.9. 12.9 in your table ni tak ada. So kita ambil approximate lah, kita ambil 13. Okay, so use your stats table. We use 5, Poisson, lambda 13. We solve for probability Y less than equals to 10. Okay, 13. So you will have 0.2517. Okay. Okay. So again, this one you have your average of errors per page is M. So that means this is your lambda. Okay. The probability that no errors are made is 0.0136. So that means you need to find what is your M. Okay. So probability x equals to 0 is 0.0136. So again lah, use the probability mass function. Exponential negative m, m to the power 0 divided by 0 factorial equals to 0.0136 and then solve for m. So you get m equal to 4.3. Okay. So that is for one page. For 3 page, so that's mean 3 times 4.3. Okay. Again, 12.9 is not included in your stats table. So kita ambil approximate which is 13. Okay, then you solve that. Okay. So that one is for Poisson, Poisson distribution. Okay. So again, Poisson related to binomial. And then this one is just, you want to find what is your lambda. Once you already get your lambda, and then you can solve the question. Okay.